In this tutorial, we are going to learn how to test our data access layer of the Spring Boot applications using test containers. This is the second part of the Spring Boot testing tutorial series. In the first part, we saw how to unit test our Spring Boot applications using the libraries JUnit 5 and Mockito. You can check the link in the description section for this tutorial. As always, you can find the written tutorial and the source code in the first link in the description section. So without any delay, let's start the video. We're going to take the Reddit clone application we have built in the previous tutorial as an example project for this video. So you can find the tutorial and also the source code for the Reddit clone application in the description section. So if you check the architecture diagram of the Reddit clone application, it is divided into three layers. We have the controller layer where the REST controllers are stored, and in the service layer we have the business logic of the application which are stored in the services. And in the persistence layer, we have code for all the repositories, which is storing the data into the Mysql database. So as part of the first video, we have covered the unit tests, which are mocking out the interaction between the service layer and the persistence layer using Mockito. And we cannot use any kind of mocking in the tests which we are writing for the persistence layer, because we want to actually test the interaction between the persistence layer and the database. So it doesn't make any sense to mock out the behavior, to mock out the interaction with the actual database. So to test the persistence layer, we are going to first use an embedded database called H2. And after that, we are going to see what are the limitations for using the embedded H2 database and how we can replace this embedded H2 database with test containers. If you don't know what is test containers, don't worry. We will cover this soon in the tutorial. So the first thing we are going to do is to install the embedded H2 database into our project. We can do that by adding the following Maven dependency into the pom.xml file and make sure you re-import the Maven projects by typing Ctrl+Shift+O. And after that, I'm going to create a test inside the test package. Inside the Java folder, I'm going to create a new package called as repository. And inside this package, I created a new class called as user repository test embedded. As we are using the embedded H2 database, I named this class as user repository test embedded. And inside this class, we have first the data JPA annotation. This is the annotation which is provided by the Spring Test framework. This, as you can see, it is including many other annotations, especially the auto-configure data JPA, auto-configure test database, transactional, auto-configure cache. So it auto-configures all the database and the JPA related functionalities out of the box into our Spring context. And in the next line, we have the active profiles test. I've created another profile called test, where we are storing the information about the embedded H2 database. We have the driver class name as the H2 driver and the data source URL. As we are using an embedded database, I'm going to provide the following URL, and the username and password I'm going to leave it as defaults. And lastly, the Hibernate dialect property I have provided as H2 dialect. So if we go back to the class, I have first auto-wired the user repository into the test class, and then I've created the first test, should save user. Here what we are doing is just creating a user object, just nothing fancy here, and I'm trying to save this user object to the repository. The save object returns the object which just saved as the return type. So I'm going to store this return type into another variable called as saved user. And after that, I'm going to make use of the assert.js libraries, assert that method. I'm going to pass in the saved user to that assert that method. And what I want to do now is compare this object with the actual object we have provided to the save method. So we have to recursively compare all the fields whether they are equal or not. So for that I can use the using recursive comparison method of the assert.j. So what it will do is it will take each fields one by one and compare it against each other. And for the user ID, we cannot provide any actual user ID here because this is auto-generated by the database, usually auto-incremented by the Mysql database. So we have to ignore this field in our comparison. So for that, we can use the ignoring fields method and pass in the name of the field as the parameter. So that is user ID. And once this is completed, we can just make our assertions that this saved user object is equal to the user. So this is one way of testing the interaction with the database, and the other way is to pre-populate the data without manually creating the user object and saving it to the database. So the Spring Test framework provides us with an annotation called as SQL. So what it will do is it will take the name of the SQL file as the input to the annotation, and in this SQL file we are going to actually insert the values, like insert the data into the, and in this SQL file we are going to insert the data to whatever table we like. So we can check this test data SQL file under the test Java resources folder, and here you can see that we just have a plain old insert statement. At the time of the test startup, Spring will have a look at the test data SQL file, and it will execute this SQL file and save the data automatically. And inside the test itself, we are just querying the user repository by the username. And if you go back to the test data SQL file, I have configured the username as testuser_SQL, and we are finding the user by the name the same name. So this method should return an optional of user, and in the next line we are asserting that this optional of user is not empty. So let's try to quickly run this test and see what happens. If you have a look at the logs which are generated by the Hibernate, save users through a SQL file, we don't see any insert statement, but we just see the select statement which is generated from Hibernate. Whereas if you go into the should save user test logs, and you can see that it is first inserting the data into the database, and after that we are doing the assertions based on the return value of this method. So we wrote our first repository test using the embedded H2 database, and as I mentioned before at the beginning of the video, there are some limitations in running our tests against the embedded database. Because in the Reddit clone application, we are using MySQL as our production database, and it is always advisable to run our tests against a real database, as we are testing our code in a similar environment to production. So the main pain point for using a real database for unit tests is maintenance. Right? Ideally, the tests we are writing will be executed in a continuous integration environment like Jenkins. So installing a database on the CI environment and maintaining it is a very tedious process. So to solve this problem, we can make use of the TestContainers. So TestContainers is a Java library which provides us a way to create lightweight instances of the common databases we use in production. It mainly uses Docker in the background to create a container, and we can use the database which is running inside the container to run our unit tests. So TestContainers not only supports a database, but anything which can run inside a Docker container. So if you want to write some Selenium tests, you can make use of TestContainers to quickly spin up a web browser, or if you're using any other external dependency to your application, you can create a container and make use of it in your project. So before we start working with the TestContainers, just make sure that you have the Docker engine installed on your machine. I'm using a Windows machine, so I've installed the Docker using the Docker desktop for Windows. So just make sure to install this, and after installing the Docker engine, we have to add the test containers into our Maven project. So for that, I'm going to add the following test container dependency to our pom.xml. So using this dependency, we are going to create the test containers, which runs the MySQL database inside the container. So I'm going to create a new test inside the repository package called as post repository test. Using this class, we are going to test the database interaction, which are performed through the post repository interface. Inside the test class, I'm going to annotate the class with data.jpa test annotation. So as I mentioned before, this will spin up a Spring context which contains all the database related and JPA related functionalities. And followed by this annotation, we are going to add the test container annotation provided by JUnit 5. This annotation will enable the test container functionality in our test class. So after that, we are going to use the auto configure test database annotation. This is usually part of the data.jpa test annotation. But as we are using a MySQL database from the test container, we have to explicitly specify that the Spring context should not replace the default data source. And inside the test, we can initialize our MySQL database container by creating an object of MySQL container class. which takes the name of the latest Docker MySQL image as the constructor parameter, followed by the database details and user credentials. After initializing this object, we can start the container inside the test by adding a container annotation to this field. This is also a JUnit 5 annotation. So when the time of test startup, JUnit 5 will automatically start the container for us. After that, I'm going to auto-wire the post repository inside the test class. And now let's create our test method called should save post. And in here, I'm creating a post object. And as we did previously for the user repository test, we're going to take the return value of the save method, store it in a variable, and after that we are going to use assert.js using comparison method to check if the actual post object contains same field values as the expected post object. So now let's go ahead and run this test. So the tests are passing, and if you check the logs of the tests, you can see that the MySQL container is started, and once the database is initialized, our test started the execution. And the whole test took around 19 seconds. If you're running the test for the first time on your machine, it will take a bit more time as it will try to download the Docker image from the Docker registry. So in this way, we can make use of the test containers to run the database tests. So now I'm going to create a similar test for the user repository interface. This time I'm going to name the class as user repository test. The configuration is going to be very similar to post repository test class. We have the data JPA test container, and auto configured test database annotations. And inside the test, we are again initializing the MySQL container object. And this time we are auto wiring the user repository. And inside the test method, we have the same logic as the previous test. So we are constructing the user object and saving it to the database and checking whether the actual and expected objects have same values or not. Now let's try to run both the post repository and user repository tests together and see what is going to happen. So you can see that the test took 35 seconds to execute, and the Docker container for the MySQL database is started 2 times for each test. So if I check the logs of the user repository test, you can see that the Docker host is initialized, Docker engine is initialized, and after that it started creating the container for the latest MySQL Docker image. And the same log you can also see in the post repository for the post repository test. So what we can do here is to make sure that the test container is created only once for all the tests which we are executing. So we can do that by using a Singleton container pattern, which is suggested by the test container team. So to do that, what we have to do is we have to not use the container and test containers annotation from JUnit 5. Because if we use this annotation, it forces JUnit 5 to restart the test container for each test. And that will make our test execution very slow and unmaintainable. So to get around that, we are going to move all the initialization logic into a base class. So I'm going to create on the root package another new class called as base test. And inside this test, I'm going to copy the logic for the MySQL container initialization. And here, as we are using the Singleton pattern, so we have to use a static block to initialize the MySQL container. So if I want to initialize the MySQL container start method, I have to also mark this field as static. So once I mark this field as also static, I can use the MySQL container variable here and use the start method from the MySQL container. In this way, we can initialize the MySQL container only once. And what we have to do next is to make our post repository test and user repository test extend the base test. So after that, we can remove the test containers annotation and also the initialization for the MySQL container from the post repository test. I'm going to do the same thing also for the user repository test. So now let's try to run these 2 tests again and see what happens. So now you can see that the tests took far less time than before. And if I click on the user repository test, you can see that the test container was initialized the very first time. So you can see that the test container is starting for MySQL. And if we check the post repository test, we don't see the test container initializing anymore because it is reusing the context, it is reusing the same container. So that's it for this tutorial. I hope you learned something about writing database tests using test containers, and I will see you in the next video where we are going to discuss about writing tests for our REST APIs using mockMVC. If you like this video, please don't forget to like and share the video and subscribe to the channel for more interesting tutorials like this.